Welcome to our deep dive into the world of Kubernetes and DevOps. You sent over a whole bunch of technical documents, and let me tell you, this stuff is like pure gold for anyone who, wants to really get ahead in tech these days. We're talking like practical skills, stuff that's in demand, not just buzzwords,
You're absolutely right. These are really the foundations for building and managing like modern applications. It doesn't even matter if you're working with web apps, microservices, or really anything in between. Understanding all this is essential.
One thing that really jumped out at me was a question about the different types of applications that, you've got running out there in the wild. It really makes you realize just how much Kubernetes can actually handle.
It is fascinating how Kubernetes has become the go-to platform for such a wide range of applications. I mean, we're talking Java Spring Boot, Node.js apps, complex microservices architectures, databases like MySQL and MongoDB, message brokers like Apache Kafka, monitoring tools, like Prometheus and Grafana, even entire CI/CD pipelines running on Jenkins, all containerized with Docker. Really a testament to Kubernetes' flexibility and power.
Okay, so Kubernetes can handle a lot, but then there's the question of, how you manage sensitive information like passwords, API keys, all that. I saw a suggestion to put secrets in config maps, and honestly, that made me a little nervous.
Yeah, that's a definite no-no from a security perspective.
Yeah.
Config maps are really designed for configuration data, not sensitive stuff. That's where Kubernetes secrets come in. They're specifically built to store and manage secrets securely.
So if config maps are out, how do you actually get those secrets into your pods without compromising security?
Well, there are a couple of ways to do it securely: environment variables and mounted files. Kubernetes can inject those secret values directly into a pod's environment, making them accessible to your application. Or you can mount the secret as a file within the pod, which is handy for applications that are designed to read secrets from a specific file path.
Makes sense. Now let's say you've got a bunch of pods running, maybe 20 or so, and things start to slow down. How do you even begin to figure out which one's the resource hog? It feels like, trying to find a needle in a haystack of code.
Well, instead of needles and haystacks, think of it more like using a powerful set of tools. In this case, we're talking about kubectl debug, which lets you attach to a running container for live debugging.
Wait, hold on, live debugging? Inside a running container? That sounds incredibly useful. Can you give me an example?
Sure. Let's say you have a pod that's experiencing, performance issues. You suspect a memory leak in a specific container. With kubectl debug, you can attach to that container, use tools like Strace or GDB to analyze its behavior in real time, pinpoint the leak, and even patch the code live.
Okay, now that's next level debugging. But let's say you've identified the problematic pod. How do you actually fix it?
Well, that really depends on the specific issue. Sometimes it's as simple as, increasing resource limits for the pod. But in other cases, you might need to optimize the application code, adjust configuration parameters, or even scale out the deployment.
This is where things start to get really interesting. I'm picturing all these pods working together, some needing more resources, others humming along efficiently. It's like an intricate dance, and we need a way to see the choreography.
Exactly. That's where the dynamic duo of Prometheus and Grafana steps in.
Monitoring. It's one thing to identify a problem, but it's another to visualize it in real time and understand the bigger picture.
Prometheus acts as your data detective, continuously gathering metrics from your Kubernetes cluster. It's like having a constant pulse on the health and performance of your applications and infrastructure. And Grafana takes that raw data and transforms it into beautiful, interactive dashboards.
Okay, so let's say we've got those 20 pods from before. How would we set up Prometheus and Grafana to monitor their performance? What's the first step?
First, you'll need to deploy Prometheus and configure it to scrape metrics from your pods. You can use Kubernetes Service Discovery, which allows Prometheus to automatically detect and monitor your pods as they come and go.
So we've got Prometheus gathering all this data, but what about Grafana? How do we get it to display that information in a way that's actually, useful?
Grafana is incredibly flexible when it comes to visualization. It provides a wide array of pre-built dashboards specifically for Kubernetes, or you can create your own custom dashboards tailored to your needs. Want to visualize CPU usage for all your pods? No problem. Want to track request latency for a specific service? Grafana can do that too.
That's the beauty of a good visualization. It can take complex data and make it instantly understandable. But let's shift gears for a moment and talk about another crucial aspect of DevOps infrastructure management. Specifically, I'm curious about Terraform and its ability to handle, unexpected changes. Let's say someone accidentally deletes half of your virtual machines. What happens when you run Terraform apply in that scenario?
One of the things that makes Terraform so powerful is its ability to, reconcile your desired state with the actual state of your infrastructure. In the case of those missing VMs, Terraform would detect the discrepancy and automatically recreate them, according to your configuration files.
That's reassuring to know. It's like having a safety net for your infrastructure. But what if you intentionally want to force Terraform to recreate a resource? Maybe you know something's messed up and you need a fresh start.
Terraform provides a command called Terraform Taint, which allows you to mark a specific resource for recreation during the next Terraform apply run. It's essentially telling Terraform to disregard the existing resource and create a brand new one from scratch.
That sounds incredibly useful for troubleshooting or when you need to ensure a resource is completely rebuilt. But with great power comes great responsibility, right? We're talking about managing infrastructure here, and those Terraform state files are like the blueprints to your entire system. How do we make sure those blueprints are secure?
Securing your Terraform state files is absolutely crucial. You don't want any unauthorized access or, accidental modifications. There are several ways to approach this, starting with encryption.
So we're talking about encrypting the state file itself using strong encryption algorithms.
Exactly. This ensures that even if someone gains access to the file, they won't be able to decipher its contents without the encryption key.
That's a good start, but what about where those files are stored? Is it safe to keep them locally on our machines?
While you can store state files locally, it's generally not recommended for production environments. A better approach is to use remote backends. Cloud providers like AWS, Azure, and Google Cloud offer secure storage services with, robust access control mechanisms.
So instead of keeping those critical state files on my laptop, I could store them securely in the cloud with fine-grained control over who can access them.
Precisely. And many of these cloud providers offer seamless integration with Terraform, making it really easy to configure and manage your remote backends.
This is starting to paint a much clearer picture of how Terraform works in a real-world setting. But we haven't talked about access control yet. How do we ensure that only authorized individuals can modify those state files?
Access control is paramount. You can leverage identity and access management (IAM) roles and policies provided by your cloud provider to restrict who can view, modify, or delete your Terraform state files. The key is to follow the principle of least privilege, granting only the necessary permissions to those who absolutely need them.
That makes perfect sense. So we've got encryption, secure storage in the cloud, and granular access control all working together to protect our infrastructure blueprints. Are there any other best practices we should keep in mind when it comes to managing Terraform state files?
One more best practice is to enable versioning for your state files. This allows you to track changes over time and, if necessary, roll back to previous versions.
So it's like having a time machine for your infrastructure. You can revert back to a known good state if any accidental or malicious changes occur.
Precisely. Versioning is your best friend when managing Terraform state. Now let's talk about a handy Terraform construct called for each.
Oh yeah, I remember seeing that in the documentation. It looked a bit intimidating, like some sort of advanced looping mechanism.
It's actually not as complex as it seems. For each allows you to create multiple instances of a resource or module, based on a set of data. Think of it as a supercharged loop for creating infrastructure dynamically.
Can you give me a concrete example of how you might use for each?
Absolutely. Let's say you need to provision 100 virtual machines, each with slightly different configurations. Instead of writing 100 separate resource blocks, you can use for each to define a single resource block and then iterate over a list of configurations, dynamically creating those VMs with the appropriate settings.
That sounds incredibly efficient. It saves you a ton of time and effort and probably reduces the chances of making mistakes. It's like automating the boring stuff so you can focus on the bigger picture.
Exactly. For each is a must-have tool in your Terraform toolbox, especially when dealing with large-scale infrastructure deployments.
All right, I'm convinced. For each sounds like a game changer. But let's shift gears back to Docker for a moment. We talked earlier about the magic of multi-stage builds and how they can result in smaller, more efficient container images. Can you walk me through how they actually work?
Multi-stage builds allow you to break down your Docker build process into distinct stages, each with its own purpose. The beauty of this approach is that you only keep the artifacts you need for the final image. All the build tools, temporary files, and intermediate dependencies are discarded, resulting in a leaner and more secure image.
So instead of cramming everything into one giant image, you're essentially creating a streamlined, production-ready image.
Exactly. Yeah, it's like Marie Kondoing your container images, getting rid of all the things that don't spark joy. This results in faster deployments, reduced storage costs, and a smaller attack surface for potential vulnerabilities.
I love the Marie Kondo analogy. It makes so much sense. But I imagine there's a trade-off, right? This multi-stage approach probably adds complexity to the build process.
There is a trade-off, but it's usually worth it. Multi-stage Docker files can be a bit more intricate, especially if you're new to Docker. You're essentially orchestrating a sequence of build steps, each with its own set of instructions and dependencies.
So it's about finding the right balance between efficiency and complexity.
Exactly. You need to weigh the benefits of smaller, more secure images against the added complexity of managing a multi-stage build. But in most cases, the benefits outweigh the costs, especially for production environments.
Okay, last Docker question for this part of our deep dive. Let's imagine we have a Docker cluster with multiple hosts. How do we actually deploy containers to those different hosts? It sounds like a logistical puzzle.
There are a couple of popular approaches for container orchestration. One is Docker Swarm, Docker's native orchestration tool. It allows you to create a cluster of Docker hosts and deploy services across them. When you deploy a service in Swarm, it automatically distributes the containers across the available nodes, ensuring high availability and fault tolerance.
So Swarm takes care of the container placement, deciding which host is best suited for each container.
Exactly. It's like having an intelligent conductor orchestrating your container orchestra. And you can use placement constraints to fine-tune where your containers are deployed, ensuring they land on hosts with specific resources or capabilities.
This is fascinating. It's like we've gone from manually deploying applications on individual servers to orchestrating entire containerized systems across a cluster. But I'm guessing Docker Swarm isn't the only player in the container orchestration game. So we've got Docker Swarm handling the container deployment and distribution across our cluster, but I've also heard a lot about Kubernetes. How does it compare to Swarm in the world of container orchestration?
Kubernetes is a more powerful and feature-rich orchestration platform. It kind of takes container management to another level. It's designed to handle large-scale, complex deployments, offering advanced features like service discovery, load balancing, self-healing, and rolling updates, all while ensuring high availability and resource efficiency.
It sounds like Kubernetes is the heavy hitter in the orchestration world, capable of managing those massive mission-critical deployments that we hear so much about.
It certainly is. Kubernetes has become the industry standard for container orchestration, and for good reason. It's incredibly versatile and can handle a wide range of workloads, from simple web applications to complex microservices architectures.
This whole world of containerization and orchestration is really fascinating. It's amazing to see how far we've come from the days of, manually configuring servers and deploying applications one by one. But let's shift gears back to monitoring for a moment. We talked earlier about setting up Prometheus and Grafana, but we didn't dive into the specifics of actually creating those dashboards. Can you walk me through that process?
Grafana is incredibly user-friendly when it comes to dashboard creation. It offers a drag-and-drop interface where you can select from a variety of visualization types, graphs, charts, tables, heat maps, and customize them to display the specific metrics you're interested in.
So I could create a dashboard that shows me the CPU usage of all my pods across the cluster in real time.
Absolutely. You could even set up alerts to notify you if CPU usage exceeds a certain threshold, allowing you to proactively address potential performance issues.
That's incredibly powerful. It's like having a control center for your entire Kubernetes infrastructure, giving you instant visibility into the health and performance of your applications.
Exactly. Monitoring is essential for maintaining the stability and reliability of your applications. It allows you to identify and address issues before they impact your users.
Okay, last but not least, let's touch on Apache Kafka. I know it's a powerful messaging system, but can you give me a real-world scenario where it would be incredibly useful?
Imagine you're building a large e-commerce platform. Every time a user places an order, you need to update inventory, send a confirmation email, and notify the shipping department. Apache Kafka can handle this entire workflow seamlessly.
So Kafka acts like the central nervous system of the platform, coordinating all these different actions in real time.
Exactly. Each action triggers an event that gets published to Kafka. Different parts of the system subscribe to these events and react accordingly, creating a highly efficient and scalable workflow.
This has been an incredible deep dive into the world of Kubernetes and DevOps. We've covered so much ground, from container orchestration and infrastructure management to monitoring and messaging systems. It's clear that these technologies are shaping the future of software development.
I couldn't agree more. And the most exciting part is that this field is constantly evolving, with new tools and techniques emerging all the time. It's a dynamic and challenging space that offers endless opportunities for learning and growth.
That's a great reminder. It's all about continuous learning and staying ahead of the curve. To all our listeners out there, thank you for joining us on this deep dive. We hope you've gained valuable insights and are inspired to explore the world of Kubernetes and DevOps further. Until next time, keep learning and keep building amazing things.